So we're looking at page 31 in the Unit 1 packet. We're asked to find the derivative of the dot product between the two vector valued functions r of t and u of t. So we're going to use the product rule for dot products as shown on the previous page. We're looking at r prime of t times, we'll dot it against u of t, plus r of t dotted against u prime of t. Okay. So in this case, what I did was I preemptively jotted down the two corresponding derivatives. Right? So it's just a matter of dotting those two or the corresponding parts appropriately. So I have to dot r prime against u. And we're not going to bother with simplifying because it's really just a skill that we're concerned with. But we're looking at 6 multiplied by t squared minus 3 plus 8t plus 2 multiplied by 2t plus 4 plus 5 multiplied by t cubed minus 3t. All right, and added to that, we're going to take the dot product between r and u prime. All right, so we'll multiply those corresponding parts. So I'm just going to kind of throw it right below because I don't think I have enough room along the side. Maybe I will, but we'll see. So 6t plus 8 multiplied by 2t plus 4t squared plus 2t minus 3 multiplied by just a plain old 2, and then a 5t multiplied by 3t squared minus 3. The alternative to this approach would be really, I would say up to you. You could do it this way, or you could use the alternative, which would be to dot u and r and u against one another first, and then go from there. I don't know if that's necessarily what you would want to do, but based on what you see here, I don't know that one way as opposed to the other would be easier or difficult. But I left all the space there just in case you wanted to try it a different way. / I accidentally left too much space. So I'll take that as a typo if somebody wants to submit it for some bonus credit. Now, dotting u against u prime, crossing u against u prime. Right? So that's a little bit more of an interesting kind of situation. Right? So let's expand that out, and you'll see something really nice happens along the way here. Right? So just bear in mind that part of the cross product here, or one of the factors of the cross product, is already the derivative. Right? So it would be the derivative of the first crossed against the second, so as is the second, plus the first function, u of t, crossed against the derivative of the second, so u double prime. All right, so the really nice thing that actually happens in the first step. When you cross a vector against itself, the result is 0. It's the 0 vector. So really, I just need to cross u against u double prime. So I need to run those numbers. So u double prime of t. Now these are polynomials, so it's going to make things a lot nicer. We're going to have 2i plus 0j, so I'm going to leave that alone, plus 6tk. All right, so that's what we'll be crossing. We're going to cross u against its second derivative. All right, so IJK. All right, U was, well, it was pretty beefy to begin with, but fortunately we have some zeros, or at least a zero, to be able to play with here. All right, so t squared minus 3, 2t plus 4, and t cubed minus 3t. Now my second derivative, 2, 0, and 6t. All right, so for the I component, now you could do this kind of on the fly, or you could set up your 2x2 square matrices. It's up to you. But if you just kind of do it on the fly using the cross-out technique, you could just do your diagonal down minus diagonal up based on what you see there. All right, so I'm crossing out the row and column containing an I, which means that I'm just kind of living with these two rows and columns. All right, so diagonal down would be 6t times 2t plus 4. All right, so that's the I coefficient. Air quotes on the coefficient. All right, now if I cross out the row and column containing the j, then I'm looking at the first and the last. All right. So diagonal down minus diagonal up. Just remember the j component already has a negative. So diagonal down, t squared minus 3 times 6t, minus diagonal up, 2 parentheses t cubed minus 3t. That's my coefficient of j. All right, and then for k, all right, that's also going to make use of the zero, so it's going to make things nicer. I'm working with the first two rows and columns. That's this stuff here. All right, so plus diagonal down 0 minus, so plus a minus, so we could make that change on the fly here. So minus 2 parentheses 2t plus 4, and that would be my coefficient of k. All right, so it took a little doing. I'm just going to move some things around again, but we get it, and we get it without having to do a lot of the work that we thought we might have to do going in, because it was like, oh, we're going to have to expand this with the product rule. But fortunately, we were able to make use of some